Morning everyone, myself J. Gauri Shankar from Mechanical Department. Today's our topic is find the angle between the surfaces and at the point 2, minus 1, 2. Find the angle between the surfaces at the point 2, minus 1, 2. Introduction to surfaces. Surfaces in three-dimensional space can be described by equations. The angle between two surfaces is determined by their normal vectors at a given point. This presentation will focus on calculating the angle between two specific surfaces at the point 2, minus 1, 2. Defining the surfaces. We need to define the equations of the two surfaces involved. For this example, let's consider the surfaces given by f of x, y, z equals to 0 and g of x, y, z equals to 0. The specific functions for these surfaces will be provided in the following slides. Surface equations. Let surface f be defined as z equals to x cap 2 plus y cap 2. Let surface g be defined as z equals to 4 minus x minus y. These surfaces represent a paraboloid and plane respectively. Finding normal vectors. The normal vector to a surface can be found using the gradient of the function. For surface f, the gradient delta f gives us the normal vector at any point. Similarly, we will compute the normal vector for surface g using delta z. Calculating the gradient of f. The gradient of f of x, y, z equals to z minus x cap 2 plus y cap 2 is delta f equals to minus 2x minus 2y, 1 at the point 2, minus 1, 2. The gradient becomes delta f equals to minus 4, 2, 1. Calculating the gradient of g. The gradient of g of x, y, z equals to z minus 4 of 4 minus x minus y is delta g equals to 1, minus 1 at the point 2, minus 1, 2. The gradient remains delta z equals to 1, minus 1. This vector serves as the normal vector for the plane defined by surface g. Normal vector summary. The normal vector for this surface of f at 2, minus 1, 2 is nf equals to minus 4, 2, 1. The normal vector for surface g at the same point is ng equals to 1, 1, minus 1. These vectors will help us calculate the angle between the two surfaces. Formula for the angle between two vectors. The angle between two vectors can be found using the dot product formula. The formula is given by cos of theta equals to nf into ng by 1 of nf into ng. This relationship allows us to determine the angle using the magnitudes of the vectors. Calculating the dot product. We can calculate the dot product nf dot ng equals to minus 4 of 1 plus 2 of 1 plus 1 of minus 1. The result of this calculation is nf dot ng equals to minus 4 of 1 minus 4 plus 2 of 1 2 plus 1 of minus 1 equals to minus 3. This value will be used in the cosine formula to find the angle. Calculating the magnitudes. The magnitude of NF is NF equals to root of minus 4 cap 2 plus 2 cap 2 plus 1 cap 2. This evaluates to NF equals to root of 16 plus 4 plus 1 equals to root 21. Similarly, the magnitude of Ng is bar Ng equals to root of 1 cap 2 plus 1 cap 2 plus minus 1 of cap 2 equals to root 3. Applying the values to the formula. Plugging the values into the cosine formula gives us cos of theta equals to minus 3 by root 21 of root 3. This simplifies to cos of theta equals to minus 3 by root 63. Calculating the angle theta. To find theta, we compute theta equals to across minus 3 by root 63. This calculation will yield a numerical value for the angle in radians per degrees. The angle represents the measure between two surfaces at the point 2, minus 1, 2. Conclusion. We have successfully calculated the angle between the two surfaces. The process involved finding normal vectors and applying the dot product. Understanding these concepts is crucial in fields like physics and engineering. Questions and discussions. Thank you for your attention during this presentation. Thank you.